Free audio post-production by alphonic.com.
Okay, let's unpack this. Today we're diving into something genuinely groundbreaking. It's how artificial intelligence, AI, is really starting to reshape autism diagnosis. For decades, we've mostly relied on the traditional stuff, questionnaires, clinical interviews, foundational, yes, but they have, limitations. Our mission here in this deep dive is to explore how AI is helping us get past those subjective assessments, moving towards more precise, reliable, and actually scalable ways to measure behavior. It's a shortcut, really, to getting up to speed on this cutting-edge development.
And what's fascinating here is exactly that shift you mentioned. I mean, think about genetics, neuroscience, huge leaps forward, right? But measuring human behavior for diagnosis, it often felt, kind of stuck. Maybe back in the 1950s almost. AI is changing that. It's turning behavior, which was hard to pin down, into reliable quantitative data, numbers we could actually work with. A lack of quantification. Just not enough detail in the numbers. Traditional ways often don't give you that really granular quantitative data you need for, a precise diagnosis. You're relying a lot on interpretation.
Right, subjective judgment.
Exactly. And second, maybe even more worrying, is low reliability. The stats are pretty stark, expert clinicians agreeing, only about 69% of the time. And get this, parent agreement. Sometimes as low as 0.5%. For 20, 30 years, behavioral assessment just didn't innovate much, not like other fields, until AI came along.
Okay, so given those gaps, the lack of quantification, poor reliability, how does AI actually fix that? What makes it where it gets really interesting? What's the tech?
Okay, so it starts with the basic idea. All behavior is movement.
Right.
Even talking, that's your vocal cords moving. Computer vision is huge here. It can track, get this, up to 180 different facial movements during a conversation.
Right. 180, wow. Things the human eye just wouldn't catch.
Oh, definitely. Micro expressions, tiny shifts, we miss most of that. And this creates these incredibly rich data sets, just tons of information. Then AI sorts these behaviors. Two main types. Monadic behaviors, these are actions that don't need a social context. Think repetitive movements, sensory reactions, that sort of thing. And then dyadic behaviors.
Mm-hmm.
These absolutely require social interaction, communication, social regulation, how you interact with others.
Okay.
And this is where AI's integrated approach, its multisensory thing, really shines. It doesn't just look at one thing. It pulls together different data streams all at once, builds a whole picture of the interaction. So you've got voice and speech analysis, looking at intonation, acoustic stuff, even the words people use.
Yeah.
For instance, our sources mention that individuals with autism might use fewer social words, like pronouns, or fewer thinking words. Interesting detail. Then body movement. Tracking gestures, facial expressions, body language, the whole package.
Okay.
And even physiological data, things like heart rate variability. You can get that non-invasively now, maybe via Bluetooth. So AI takes all these signals, voice, movement, physiology, and analyzes them together. That gives you a really deep understanding of how someone is engaging socially, critical for diagnosis. That's a fair point. Capturing the full range of, say, spontaneous, totally unstructured social stuff in the real world, outside controlled settings, that's still the challenge. But the tech is moving fast, very fast. And what it can do already means vastly improved diagnostic accuracy. And just measuring more things. Take language again. AI can analyze subtle things, intonation, loudness changes that signal communication differences, or motor function. Think about measuring someone's gait, their walk. Traditionally, you might need this special map, maybe $40,000.
Wow, expensive.
Yeah, but what's compelling is a simple $300 camera with AI, it can get basically the same accuracy, like 0.99 correlation for stride with posture stability.
$300 versus $40,000. That's huge.
It's one of the biggest wins. Remote data collection. Using just standard video conferencing like Zoom, you can gather data that's just as accurate as doing it in person.
Really? From a Zoom call?
Yeah. Think about a family living miles from a clinic. Hundreds of miles. Now they might be able to get an assessment from home. This also lets clinics build much bigger, richer databases, which is crucial for research, especially complex cases like autism with ADHD or intellectual disabilities.
Makes sense. More data, better understanding.
Precisely. And it massively improves access for people in rural areas or just far from specialists. Big barrier, often. And of course, it saves time and money compared to the old ways. Exactly. It also helps research,
Yeah.
confirming the biological roots of autism, really testing if new treatments work and how they work. A big focus now is data diversity, making sure that the AI isn't biased. Training it on data that reflects everyone, different genders, races, backgrounds. That's critical.
Yeah, crucial for fairness.
Absolutely. And ultimately, the goal is this comprehensive analysis, combining the behavioral data with biological data, genetics, brain imaging, whatever, getting that truly holistic picture. It really comes back to that core shift, moving diagnosis from subjective observation to objective, quantitative, detailed measurement. That enhances accuracy, accessibility, and just our fundamental understanding of autism's complexity.
So it's not just tweaking the old system. AI is fundamentally changing how we see and diagnose autism, making it objective, detailed, and reachable for more people.
Free audio post-production by auphonic.com.